Alright, so this video is an introduction to concavity and points of inflection. So what we're going to be talking about is our second derivative here. That's what's going to give us our concavity and points of inflection. So if you remember our first derivative has to deal with whether our function is increasing or decreasing. So if we have a positive slope, our function is increasing. And if we have a negative slope, our first derivative is negative, then we know our function is decreasing. So it looks like this. As we move along, our slope here is positive, and so our dot will go up. See? So our dot goes up. And then now our derivative is negative, so it goes down. So positive slope, function increases. So now what we're going to look at is our second derivative. So our second derivative has to deal with how our derivative is changing. So if our second derivative here is negative, then we get this situation here. We get a concave down. And what's happening is if you look at our slope here, it's decreasing. So like this would be 5. And then it's 0, and then like negative 5. So our slope went from 5 to 0 to negative 5. It looks like this. So if we take this all the way back, watch our slope. We have a second derivative that is negative. And our slope is now at 8, 6, 2, 1, negative. You can see that our slope is decreasing here. Our first derivative is decreasing. So if our second derivative is negative, our first derivative decreases. And now you can see our second derivative is positive, so our first derivative increases. It's going from, look at it, it's negative 1 to negative 1.08 to 0.36 to 1.44. You can see it's increasing. So it looks like this, concave up. So when you have a concave up, your second derivative will be positive. And when you have a concave down, your second derivative will be negative. And again, it just has to deal with the slope. So you can see here, this is back to 0. And then now we're back to a positive 5. So I'm just using 5 as a random number. So you can see on the negative here for our second derivative that our derivative went from positive 5 to 0 to negative 5. That's decreasing. And then on the upward, concave up, it went from negative 5 to 0 to 5. So you can see it's increasing. So concave down, decreasing. Concave up, increasing derivative. So if your first derivative is positive, our function is increasing. If our first derivative is negative, our f of x is decreasing. And then again, we get those critical numbers from when it's 0 or d and e. So the same thing kind of happens with our second derivative. If our second derivative is positive, that means our first derivative is increasing. So we get our concave up, right? And if our second derivative is negative, our first derivative is decreasing. So we get our concave down. And if our second derivative is 0 or d and e, we get possible points of inflection. So what that means is this. Right here is our point of inflection. That's where our concavity changes from down to up. And that means we would have a second derivative equal to 0. So it looks like this. Watch. We're going to start over here again. And we're going to go through it. So you can see again our derivative, our slope. You can even watch the end of it. You can see it's going down. That means our slope is decreasing. See, it's decreasing, decreasing, decreasing until it hits right there. You see our second derivative is 0. So this is concave down, and from here on, it's concave up. So it's a point of inflection. It's where it's changing from concave down to concave up. And then from here on out, you'll see that our derivative is positive. So to the left, it's negative. To the right, it's positive. See? And again, it makes sense. We're going from a negative to a positive. So what number do you have to go through? 0. So this is where your slope decreases. You can see if you watch the end of the line segment, it goes down. And then it's 0. And then now watch the end of the line segment, it goes up. So this is where our derivative increases, and this is where our derivative decreases, and that's a point of inflection. So this is what we end up with, all of these little rules down here. And so I'm going to write the slope on here just so that we have it. So this would be like a 1, and then a 0, and a -1. So you can see that it is, as we go through here, it's decreasing. And then over here, we're at -1, 0, and 1. And you can see as we go through this, it's increasing. I probably should have changed the colors, but it's too late now. That's the way they are. So -1, 0, and 1. It's increasing. So concave up, our derivative increases. Concave down, our derivative decreases. Thank you. We'll do some examples in the next video.